notation. All right. Scientific notation comes from the idea that outside of our 7th grade bubble of math, in the real world, people deal with very large things and very tiny things. And we have to measure them and work with them and weigh them. And we don't have the time to write a 13-digit number over and over because that takes a lot of time. So when you're like out in the real world and you're being a scientist, you use what's called scientific notation to, it's kind of like shorthand. So like what's something very large that you might need to weigh or measure? Give me an object. Yes. An elephant. Something bigger. Think bigger. Yes.
The entire universe.
The universe. That is a great example. If I wanted to measure the distance from one end of the universe to the other, in our earthly terms, we use things like miles and feet and kilometers. There is no, I mean, if you think about a kilometer and then you start trying to measure the universe, that's a lot of kilometers. Yes? You don't want to have to write that 16-digit number, so we use scientific notation. What's something that's super, super tiny that you might need to measure? Yes?
Little molecule.
A tiny molecule. Something else. Yes? An atom. Yes. A piece of dust. All of these things are teeny tiny. What is the smallest unit of measure you know? Yes? Is that a length? See, I don't even know. Proton? Yes.
I forgot what it's called, but it's like really, really small.
Millimeter? That's the smallest thing I can think of. A nanometer, maybe?
Yes.
A nanometer. So all of these things, if you can see it, it's not as small as we need it to be. So we're talking like I'm going to measure an electron on an atom. I'm going to measure the nucleus of an atom. We can't even fathom numbers that small, so we write them in scientific notation. So scientific notation is used to write very large and very small numbers. And I'm talking very large and very small. I'm not talking 10. I mean, not that you couldn't do 10, but that's not really why it was made. We're talking like 16 billion something. All right. I'm going to change how I go about this time around. I don't know if I like it or not. I think I still like it. Okay, we're going to split the paper in half. I'm trying to teach it differently this year than last year because last year we taught them in isolation and they got really confused when they had to go back and forth between tiny and large. So this year we're going to do them together and you're going to have to be able to go back and forth from day one. I'm going to do tiny numbers on the left and larger numbers on the right. Let's be more scientific about it. A tiny number would be less than 1. And larger numbers are going to be greater than 1. Greater than 10. Or equal to 10. Little and small. I'm sorry, little and large. For the little numbers, I'm talking 0.00000 stuff. So my example number I'm going to use is going to be I use blue, maybe different color, orange. I'm going to use 0.0000123. 0.00004 zeros, and then 1, 2, 3. All right. The first thing I do, step 1. Use that one. Step 1. Scientific notation is a digit, a decimal, the other digits. So I need to move the decimal. Which way, left or right? If I need it to be a digit, decimal, digit, do I need to move my decimal right or left? Right. Move my decimal right. How do I say it? Until it passes one non-zero number. One non-zero number. So I pick up my decimal. What number did I just pass? Okay. What number did I just pass?
0.
What number did I just pass?
0.
What number did I pass? What number did I just pass? Stop. That's where we stop. So what is my number now? 1.23 or 1.23. Okay? That's the first part. Second part. Sorry. Step 2 is how many jumps did you just go? How many, we'll just say jumps. So how many did you go? 5. 1, 2, 3, 4, 5. I'm going to insert a question. Nope, I'm not. All right, so I take my answer from number 1, 1.23, and I'm going to write it 1.23. This next part is because it's scientific notation, times 10. This is always going to be times 10. This is what makes it scientific notation. Then I take my exponent and I put it here. Now, what is 10 times 10 times 10 times 10 times 10? Is it a big number or a little number? It's a huge number. If I multiply 1.23 times a huge number, is it going to give me a little number? Yeah. No. So I have to make this a negative 5. So this side, little numbers, the exponents are negative. Negative exponent. If it's a little number, it gets a negative exponent. This is technically 1 over 10 with 5 zeros. Y'all will do that in 8th grade. Yeah. That's it. That's little numbers. Little numbers, the hardest part is remembering that it's a negative exponent. Now let's do a big number. If I have the number 32832,500,000,000,000. Let's make it worth it. So that is 3, 6, 9, 10 zeros, 5823. 3, 2, 8, 5, and then 10 zeros. I don't even know. That's hundreds, thousands, millions, billions, trillions? 32,850,000,000,000. That's it. Now, just like over here, I moved my decimal until I passed one digit that wasn't 0. Over here, I need to move my decimal to the left until there is only one digit left. Move decimal left until only one digit in front of decimal. So if my decimal is here, how many jumps is it going to take until there's only one digit in front? Tell me when to stop. Stop. Is that one digit? Nope. Keep going. Now is it one digit? No. Now is it one digit? That's when I stop, right there. How many jumps was that? How many jumps? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 jumps. Oh, I forgot to write down my number. Your number is 3.285. Step 3, I take this number. So it's going to be 3.285 times 10 to the what? Positive 13. So little numbers get negative exponents. Big numbers are going to get positive exponents. Here's an example of where you may have seen scientific notation before. Yes. That's okay. Oh goodness. So if you had 50 times 2 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 times 1 billion. I need this to get bigger faster. Okay. This is scientific notation. It's a 6-4 with 20 zeros, or 6-4 with its 19 zeros, because it would move 20 times to the right. So we've got this one. This is called standard, or sorry, this is scientific notation. That E means times 10. If you turn it this way, that's the whole number. So this is standard form. That's scientific notation, more or less. So that would be my exponent to the 13th. So it would be 9, 6, blah, blah, blah. It would just keep going. That's standard form. I don't want to write all of that. That's going to take me too long. So we write it like this. Got it? Big numbers get positives. Little numbers get negatives.